Welcome to the IMRAN Academy. I am discussing with you FSC Part 1 Chemistry, Chapter 9 Numericals. Here are some important formulas. The first formula is for molarity. It is represented by capital M and it is equal to number of moles of solute over volume of solution in dm cube, or you can write it as I have just written the formula for number of moles, which is equal to mass of solute over molar mass of solute multiplied by 1 over volume of solution in dm cube. So this is the formula for molarity. Now we have molality, and it is represented by small m, and it is equal to number of moles of solute over mass of solvent in kilogram kg, or you can write it as molality small m equals number of moles. Formula is applied here, which is equal to mass of solute over molar mass of solute multiplied by 1 over mass of solvent in kilograms. So this is the formula. I have given you both the formulas. Let's move to the next part. The next part was numerical number 17, A part. Calculate the molarity of glucose solution when 9 grams of it is dissolved in 250 cubic centimeter of solution. Here we have 9 grams of solute, that is mass of solute is given, and the solute in this case is glucose. So mass of glucose is 9 grams and volume of solution is also given as 250 cm cube. 250 cm cube, and we want to convert this cm cube into dm cube. Here is the process that I discussed with you in the previous lecture. For a shortcut, you just divide the figure with 1000 and you will change cm cube into dm cube. Just divide the number with 1000 and the cm cube will be converted into dm cube. So volume of solution is this one, 0.25 dm cube. Now we want to find the molarity. For that we must know the number of moles, and to find the number of moles we must have molar mass of glucose. So the molar mass of glucose is the atomic mass of carbon is 12 and it has 6. We have 6 atoms here in the formula of glucose, so we will multiply 12 by 6, plus the atomic mass of hydrogen is 1 and we have 12 atoms of it, so we will multiply 1 by 12. Similarly, the atomic number of oxygen, atomic mass of oxygen is 16 and we have 6 atoms of it, so we will multiply 16 by 6. After calculation, we get the molar mass of glucose as 180 grams per mole. Now we can apply the formula. We have molar mass, we have mass of solute, molar mass of solute, and volume of solution in dm cube. So here is the formula for molarity, capital M, mass of solute over molar mass of solute multiplied by 1 over volume of solution in dm cube. Mass of solute is, that is glucose, is 9 grams over mass of molar mass of glucose is 180 grams per mole times 1 over volume of solution in dm cube is 0.25 dm cube. So after multiplying these terms, this G will cancel out with this G and this per mole will become mole, and this dm cube after going up will become per dm cube. And after using the calculator you can just find the answer. So the molarity capital M is equal to 0.2 moles per dm cube. Let's move further. Now we have its B part, which is equal to calculate the mass of urea in 100 grams of water in 0.3 molar solution. Here we will use the formula for molality, but first we will find what is required in molality. Molality requires number of moles of solute over, this is the formula for molality, number of moles of solute over mass of solvent in kilogram. Number of moles of solute over mass of solvent in kilogram. So we need number of moles of solute, and in this case we have solute as urea. We have urea as solute, so we need to find the number of moles of urea. For that we need its mass, which is given. I think it's not given. Mass of water is actually given, and which is our solvent, and we want to convert this mass into kilograms. It is given in grams and we want to convert this into kilograms. So in kilogram we have 0.1 kg mass of water. Next we want to find the mass, or we want to have the number of moles, but we can't find it because we are not given the mass of urea. Actually we want to find the mass of urea. The molality small m is given as 0.3 mole per kg. So we know the formula of urea, that is NH2CONH2. The thing that we can do is we can find the molar mass of urea. Here we have 2 nitrogen atoms. The atomic mass of nitrogen is 14, and we will multiply it by 2 because we have 2 nitrogen atoms. Next we have 4 hydrogen atoms. The atomic mass of hydrogen is 1. We will multiply it by 4. Then we have carbon, its mass is 12. Then we have oxygen, its mass is 16. After adding all these numbers, we get 60 grams per mole, which is the molar mass of urea. Now we have molality, we have molar mass of urea, and we have mass of solvent in kg as well. Now we can easily apply the formula and find the missing term. Here is the formula for you. Molality small m equals mass of solvent over molar mass of solvent multiplied by 1 over mass of solute over molar mass of solute multiplied by 1 over mass of solvent in kilograms. The solute in our problem is urea, so we will apply all the terms, all the values. We have molality as 0.3 moles per kg. Mass of urea is unknown. Molar mass of urea we have calculated as 60 grams per mole in times 1 over mass of solvent, that is water, in kilogram is 0.1 kg. So we take all the terms to the other side. This kilogram will cancel out this per kg, and this mole will cancel out with this per mole, and we will have just the number 0.3 multiplied by 60 multiplied by 0.1. So after multiplying all these numbers, we get this gram as well. Here you will just end up with a gram. All the other units will cancel out. So we have mass of urea as 1.8 grams. Now we go to next part, which is C part of this problem. Calculate the concentration of a solution in moles per kg, which is obtained by mixing 250 grams of 20% solution of NaCl with 200 grams of 40% solution of NaCl. We have two solutions, one is 20% and the other is 40% NaCl. The first solution has 250 grams and the other solution is 200 grams. So in this case we have percentage of NaCl solution. The first solution is 20%. So mass of 20% solution of NaCl is given as 250 grams. We want to find the concentration of solution. After mixing both the solutions, we want to find the concentration of the solution that is created after mixing the two solutions. Now we again come to the first solution. 20% solution of NaCl means, what is the meaning of 20% solution? It means that in 100 parts of solution, NaCl is only 20 parts. That is 100 grams of solution will contain 20 grams of NaCl. If I take this 100 to the other side, here I will left with 1. So 1 gram of solution is equal to 20 over 100 grams of NaCl, but I have 250 grams. So I will multiply both sides by 250 grams. So 250 grams of solution contains 50 grams of NaCl. Similarly, percentage of NaCl solution, the second solution is 40. So it means mass of 40% NaCl solution is also given as 200 grams. Solution's mass 200 grams. Similarly, we can say that 40% solution of NaCl means that in 100 grams of solution we will have 40 grams of NaCl. So taking 100 to the other side, 1 gram of solution contains this number of NaCl grams, and we have 200 grams of solution. So multiplying 200 on both sides, we get 80 grams of NaCl. So 200 grams of NaCl solution contains 80 grams of NaCl. So mass of NaCl in both solutions, we will just add the numbers, 50 grams and 80 grams, 130 grams. So total mass of NaCl is 130 grams. Total mass of solution is 200 grams plus 250 grams, which is equal to 450 grams. So let's move to the other side. Now only thing that is missing here is the molar mass of NaCl. The molar mass of NaCl, we can calculate it here. Molar mass of NaCl. As we know, sodium is 23 and chlorine is 35.5, which is equal to 58.5. Mass of solvent solution, we can find the mass of solvent as the mass of solution minus the mass of solute. Mass of solution minus the mass of solute. So we've got the mass of solvent as well. It was in grams and we have converted into kilogram by dividing it by 1000. Now we can find the molality. Molality is mass of solute over molar mass of solute multiplied by 1 over mass of solvent in kilograms. So mass of solute is 130 grams, molar mass 58.5 grams per mole, and here we have kg, and molality, we can just find the molality. Which is equal to mole per kg, mole per kg. So after using the calculator and just simplifying the problem, we get 6.94 mole per kg, molality. Molal, we can also write it as molal. So this is the answer to our problem. That was the previous question. Now we go to the next question. This was our question number 17. Now is question number 18. Let's do it on another page. Question number 18. And the question is, A part is an aqueous solution of sucrose has been labeled as 1 molal. Find the mole fraction of the solute and the solvent. In this case, again we are given a solution which is 1 molar. In the previous case, we studied here that 1 molal means mole per kg. 6.94 molal means mole per kg. So mole per kg, you should remember it. Mole of solute and kg of solvent. So here molality is 1 and mass of solute, which is in this case is 2O11. It is unknown, but we can find its molar mass. Molar mass of solute, that is C12H22O11, sucrose. So we can find the molar mass of it. Here we have carbon 12 multiplied by 12, hydrogen 1 multiplied by 22, plus oxygen 16 multiplied by 11. Just use your calculator to find the mass of this. So the total mass that we can find in this case is 342 grams per mole. As we know that the solution is 1 molar, it means that 1 mole of solute is dissolved in 1 kilogram of solution of solvent. In molality, 1 mole of solute is dissolved in 1 kg of solvent. So we can just find the mass of solvent, which is equal to 1 kg, and we have deduced it from 1 molar. 1 molar is equal to 1 mole per kg, 1 mole per kg. So the mass of solvent is 1 kg. Now we apply the formula for molality. Formula for molality, small m is equal to mass of solute over molar mass multiplied by 1 over mass of solvent in kg. Let's apply the values. Here we have this solution is 1 molar, we apply a 1 here. The mass of solute, that is sucrose, is not given, so mass of solute is unknown here, over molar mass 320 grams per mole into 1 over 1 kg. So these are the values that we have. It is mole per kg. So taking all the values to one side, mass of solute is equal to 1. This mole and per mole will cancel out, this gram and kg and per kg will cancel out, and we will left with gram only. So what we get here, 342 grams. So mass of solute, that is sucrose, is that much. Now, as we already know that number of moles, from the definition of molality, number of moles, this 1 molar shows that the number of moles of solute is 1. But anyway, we can apply the formula as well to find the number of moles of solute. It will be 1, of course. Number of moles, we are out of focus. Number of moles of C12H22O11 is equal to mass over molar mass. Both are the same. It is also 320 grams, and this is 342 grams and 342 grams per mole, and the answer is 1 mole. So the number of moles we have found. Now we can find the number of moles of solvent as well. That is water. So number of moles of C12H22O11 is this one. Now we find number of moles of water. Number of moles of water, that is mass over molar mass. So mass of water is 1 kg, which is 1000 grams, and molar mass, we know that the molar mass of water is 18 grams per mole. Oxygen is 16 and there are 2 hydrogen atoms, so 16 plus 2 is 18. So we get the answer of 55.56 mole. These are the number of moles of water, which is our solvent. So total number of moles, total number of moles is equal to 1 plus 55.56, which is 56.56. So these are the total number of moles that we have. What will we do now? Now we can find mole fraction easily. Mole fraction of water, which is equal to 55.56 over 56.56. The total of water moles and water moles over total. So the answer to our problem is, with the help of calculator, we find it as 0.9823. 0.9823. Similarly, we can find the mole fraction of sucrose. It is 1 over 56.56, which comes out to be 0.0176. So this is one answer. And this is the other answer. We have actually found the mole fraction of both quantities. I am just running out of time because I am getting late. I must go to my office. And thanks for watching. Inshallah, in the next lecture, I will try to solve the other part, and maybe the next numerical, that is 19, numerical number 19 as well. Till the next lecture, it's goodbye. If you are a new viewer to my channel, the IMRAN Academy, please subscribe to IMRAN Academy for more lectures in the future. Please do like, share and subscribe. and hit the bell icon as well. Thanks for watching. Till the next lecture, it's goodbye.